UAA NCR lecture series lecture is by our very own Siddhant Varshney. He is BTech and MTech from ICT in 2015 and 18 respectively. He is now running his own show in the form of an organization called Sunshine Chemtech, in which they manufacture a wonderful product that is kind of a monopoly, that is white graphene. Now, Siddhant had been a wonderful person from the point of view of his academics. He had been a research associate with IIT Delhi and DRDO from 2018 onward for some time, before he plunged into Sunshine Chemtech. Now, Siddhant, besides being a technical person, is a very, very spiritual person. He's a person who's associated with Art of Living organization. And he's working very closely with Sri Ravi Shankar ji on national level projects. And he's the part of the Delhi Secretariat of Art of Living. Besides, he has been a wonderful sports person. He is the one who built the turf court at UDCT. And we brought UDCT or ICT for that matter, #2 position as far as in India on the sports arena. He is a very strong marathon runner, runs 21 kilometers marathon. He has done it 8 times. He's a national level lawn tennis player. And coming back to his organization, Sunshine Chemtech has grown into a multi-crore turnover company within past just 1.5 years. Just 1.5 years, I'm repeating. Sunshine is India's only company manufacturing white graphene and is one of the 3 manufacturers in the world. And what else to say about Mr. Siddhant? Siddhant, I leave it on to you to now explain further. Go ahead with all the gut and feelings you have for us. All the best to you. Take it on.
Thank you for the lovely introduction. And I will start with my presentation, and it will be a quick 45 minutes presentation, and it will be majorly into the technology of graphene. I will not do any publicity of the company or anything. And if any questions, you can please ask me in the ending 15 minutes of the time. You can raise your hand as well if there are many questions. So I will just start with the presentation. I hope you can see my screen.
Yes, yes.
So, role of graphene as a super nano additive in the current chemical industry. So, I'll just introduce you to graphene. Graphene is basically a 2-dimensional sheet of carbon atoms which are sp3 bonded. Sp3 bonded basically means that they are all in their stable state, and it is a honeycomb lattice. Now, it is known for its high conductive properties. It is a nano material. It is mostly sold in powder form or in colloidal form, but 80% you can say is sold in the powder form, which is then processed. It has excellent conductivity, it has high flexibility, it imparts a lot of strength. So just for an example, 1 weight % of graphene in a plastic which is compatible plastic, for example polyurethane, increases the tensile modulus by 300% just by 1 weight % of graphene addition. It is used in a lot of applications: sensors, material science, electronics. Now the brother of graphene is graphene oxide. Graphene oxide, as you can see, the structure is is nothing but graphene, but having oxygen functionalities: hydroxyl, carboxyl, and epoxy functionalities. So these are the only 3 functionalities that are there in addition to graphene. Its application, so it is basically a hydrophile. That means water loving. So it disperses very well in aqueous solutions, aqueous mediums, in comparison with graphene. For graphene, there are solvents like NMP, etc., N-methyl pyrrolidone. But for graphene oxide, it can be dispersed even in water. Normal tap water also it can be dispersed. once it goes into the material, it changes its property to hydrophobic property. So in the dispersion, it is hydrophilic, but once it goes into a plastic or any application, it makes that material hydrophobic. It is again used in energy storage, membrane technology, and biomedical applications. In membrane technology, it can desalinate seawater, by 99.9% efficiency at 20,000 psi. The conversion is just like this, that uh, graphene, graphite, you can say, graphite is oxidized to graphene oxide, and then graphene oxide is reduced to graphene. So this is how generally a synthesis method is done, that you take graphite and you oxidize it to graphene oxide. You can't get direct graphene by a large scale synthesis method. You can have small scale synthesis methods for getting direct graphene, but for large scale synthesis methods, you have to first oxidize graphite into graphene oxide and then reduce it further into graphene. So these are the this is just a market analysis and overview. You can see how much investments are being done. It goes up to thousands of millions of dollars. This data is of late 2022 and early 2023, so it's quite recent. You can see that in the European market projection. In the European market projection, it is at least 1,800 million pounds. That is the forecast that it can contribute to the GDP. And global graphene market, you can see the green curve over here. The green curve on the right side is the maximum scenario, and even if you take the median or the average, so at least $2,000 million, the revenue will touch. You can all mute yourselves. Yeah. So it will touch within 2024, and it can go up to 5,000 or even $10,000 million within the next year. Then you can see the volume demand forecast. The volume in tons. In tons, it is going to almost 10 million tons, by the end of 2025. It will at least cross 1 million tons of demand worldwide. And the global prices, as you can see, so the pricing that we are offering is around $400 $450 per kilo, but you can see it ranges from $50 to $1,000 per kilo. So the $50, like the range between 50 to 500, 50 to 300, you can say, is majorly expanded graphite. It is not graphene exactly, but people sell it in the name of graphene. So it is for your own knowledge, that you should know that how much graphene is priced, and when you go to buy graphene, you should go for somewhere between $400 to maybe even $800. $1,000 are for the super specialty graphene, which are just one layer or maximum 3 layer thick. The graphene that is being commercially sold is generally 5 to 7 layer thick. Then you can see the mentions per country. Mentions in the sense that mentioning in terms of research uh, uh, research area, or mention in terms of business. So India is still lacking behind with respect to US, UK, China, Canada, and Spain. It is lagging behind, although US has a huge footprint in graphene, and the market over there is almost saturated. You can see the top 20 companies that I have listed on the right hand side. UK, Spain, US, Canada. So UK, you can see the names, Hedel, Graphenia, ACS Material, which is an LLC. So not all graphene companies have to be a you can also have a LLC. There are lots of entrepreneurial um, opportunities in graphene, especially from India, because you can see India is not mentioned in the top 3
टॉप लेवल में मैं कंप्लेंट किया फिर एक आया
yeah. So ACS, Nano Explore, Graphene Nanochem, Graphoid, all these companies are there, but none of them are from India. So this is a good opportunity where, because India is a really good exporter and importer of graphene, but we should not rely completely on foreign countries, because India can also really give out excellent quality graphene products. So there is nothing like, you take it from foreign, the graphene will be better or something like that. No, it is not like that. Maybe for other materials, maybe for even RO membranes, but slowly we are shifting to indigenous supply, and make in India is what we all believe in, and we should all believe in. India has a good uh, opportunity. Even Reliance, Aditya Birla, these kind of companies have also jumped into graphene uh, uh, business. And this is the market analysis for the transnational patents. Now here you can see India. So the number of patents in the US come close to about 3,000, but in India, it is touching 1,000 patents. So we are not very far away. As you can see, we are a good patent provider, patent generator. India is a very good patent generator, but somehow in the commercial aspect, we are left to rely on the foreign countries. This is just our mentality. This has nothing to do with the ergonomics or the or anything technical aspect or anything like that, but this just has to do with our mentality. So in India has a lot of potential for this kind of business, graphene business. I request you all to mute yourselves. Mute yourselves. Akash ji, please mute yourself. Okay. Sector wise, if you see on the left hand side, CAGR, that is cumulative average growth rate. So you can see total composites, electronics, and batteries. So graphene is majorly utilized in composites, polymer nanocomposites, in batteries, and in electronic applications. So composites, you can see graphene total is very unpredictable. So you can see not a good fit is being generated from the overall total section of graphene, because graphene is very versatile. You don't know how many more applications it can come in. It is finding new applications every year. So all those that's why there's a big gap between the black dots and the yellow dots over there. So if you see the yellow dots, graphene composites, it is $10,000 million revenue in 2022. So and the the growth rate is also it is very promising. And on your right hand side, you can see the time development of patent applications with respect to graphene. So uh, in terms of composites, it is doing really well. In terms of composites, the number of patents are rising per year. So overall the trend is rising only. It has fallen between 2018 and 20, not even 18 and 20, 19 and 20, majorly because of COVID. But post that, the growth is quite unilateral. It is increasing for all aspects: electronics, batteries, composites, paints also, even paints. Synthesis techniques of graphene oxide. Now I'll just touch a little bit upon the chemical aspect. So there are majorly these methods: Hammer's methods, Todenmeyer, Brody, improved Hammers. So these four methods are chemical methods, and the fifth and sixth, CVD and epoxide ring opening, they are a little bit different. Majorly, people go with CVD or they go with improved Hammer's method. So in Hammer's method, basically graphite is oxidized to graphene oxide, and then graphene oxide is later reduced to graphene, but it is hazardous. This method is highly hazardous. It is highly explosive because of hexavalent manganese ions. So there's a temperature 55 degrees Celsius. If you, I mean, you should know all this so that you know you can, if you want to work with graphene, this is some safety precaution that you have to take. At 55 degrees Celsius, if you there's a reaction which goes on for 12 hours, but that is highly explosive. So even if the temperature increases by 1 degree, it goes to 56, suppose, or if you're doing it in a large scale reactor and you're having eddy pockets, thermodynamic pockets that are being formed where the heat dissipation is not homogeneous, that time explosion can happen, and many explosions have happened even in the research aspect, at small scale in laboratories, and at large scale also, at commercial scales as well. So my research involved finding out a synthesis method which has no explosion, which gives no explosion, and which can be synthesized at a large scale. This white graphene was actually I came upon it by mistake, you can say. When all great inventions are done by mistakes. So I was just creating a batch, and then I just got white graphene once. So we started up something of our own. You all also can do it if you are interested in graphene. Just study these methods, and you can develop your own method later on as well. Staudenmayer method. This uses KClO3 instead of NaCO3. It uses KClO3, and the amount of oxidation that is generated from Staudenmayer is a little bit less, but it has a high control over the degree of oxidation. You can set, like, you can plan like how much acid value or how much hydroxyl value you need from the graphene, which is important for some pH applications, because graphene oxide can have a pH up till 3 as well. In the aqueous solution, it can be highly acidic. Then Brody method, I will just skip over quickly. So these are just small, and these methods are time tested. They were developed in 1950s, 1960s. So these methods are highly, I mean, they are time tested, but they are quite explosive. This type of chemistry was applied to graphene later on, after 2000s, after the early 2000s, when graphene was actually discovered in the early 2000s, when it was discovered by Scotch tape method. So they were just peeling off layer by layer by using a Scotch tape, and they got a two-dimensional two-dimensional layer. And I request you all to mute yourselves. Swapnil ji, Akash ji. So improved Hammer's method. Improved Hammer's method only uses orthophosphoric acid, that is H3PO4, and the chances of explosion goes down a lot, substantially. Chemical vapor deposition, CVD. It is done by heating a solid precursor, and the gases are collected at a tube, and those gases are layer by layer grown into graphene. So for example, alkyne gas is collected on a substrate, and alkyne is slowly grown into graphene, layer by layer, by CVD method. But CVD is time taking, and it cannot give you very large scale results, although the product quality will be very good. So you can play on the quality and the scale. Epoxide ring opening is you introduce a chemical for example, ODMT or an amino alkyne, and you open the chain, so by chain opening, by cycle opening, it's called cyclization or decyclization reaction. So you can have a decyclization reaction and also get graphene, or you can include functional groups also in graphene. This is just a dynamic comparison. You can have a quick look through. Okay, now why use graphene oxide in paints? Now I will go from each sector to each sector: paints, polymers, batteries, membranes. So why use graphene oxide in paints is firstly because it has high barrier properties. Okay, barrier properties in the sense that it will, for packaging applications, it is very good for packaging applications. And gas barrier, so helium is the smallest molecule, hydrogen is the smallest, but also helium, helium and hydrogen are the two smallest gases that are known, and they penetrate through any substrate easily, if you have a film. So it can go into packaging, and for films also, for the paint also. Paint is nothing but a polymer layer. So a liquid polymer which can be, applied on a substrate is called as a paint. So it will not allow any chemical or any kind of a gas or anything, any kind of corrosive substance to enter the substrate, so it will form a protective layer. Mechanical strength and durability, it improves the mechanical strength by 300%, as I already told you, by just including 1 weight% of graphene in the matrix. Durability, it is highly durable, and the loadings that I'm talking about in any application goes from 0.3 weight% to maximum 3 weight%. Nowhere it is used beyond 3 weight%. Very few applications. So we are just playing between 0.3 and 3 weight%. So alkali resistance, chemical resistance, acid resistance, all these things are given by graphene. Corrosion resistance, it works wonders with corrosion resistance. It gives you 1,000 hour salt spray result. So salt spray test, generally 300 hours is what is the standard for approval into anti-corrosion segment, but this goes for 1,000 hours, which is a very good milestone. And thermal conductivity, graphene itself is highly thermally conducting yet thermally resistant. So it is highly conducting, but it can increase the thermal resistance of any polymer in which it is going into. So the thermal resistance of graphene is approximately up to 800 degrees Celsius with no change in the chemical structure, almost no change in the chemical structure. And also it is highly thermally conducting. Its thermal coefficient I mean, it allows it to conduct heat efficiently and also dissipate heat. And it is highly conducting in terms of heat, and it is highly conducting in terms of electricity also. Fire retardancy, you can see for intumescent coatings, it can be applied. UV resistance, you get high UV resistance. All these properties you're getting just by one chemical, that is graphene. Antibacterial properties, anti-fouling, it can go for anti-fouling in marine paints. In fact, even for COVID, some people have used graphene in their masks. So the thing that they were generally using was silver nanoparticles, or quantum dots, something like that. But the best, the most cost effective and most advanced technology is using graphene in the masks. People are using graphene for anti-fouling polymer nanocomposites, like tank, for the overhead tanks where water is kept for a long time, so algae and fungi can start growing. So it is used for that, for avoiding that enhanced adhesion you get, because it plays with the surface energy of the substrate. So because of that, you get high adhesion, you get excellent electrical conductivity, and it is very versatile material. And you can see the TEM analysis. For those of you who know what is TEM, TEM is basically just like an X-ray of the particle, of the nanoparticle, and these sheets that you can see, this is like a sheet, this is like a like a blanket, you can say. Mohanji, you can mute yourself. Yeah, like a blanket. So it is very thin. This is just like 3 to 4 layers of graphene. You can have single layer of graphene also, but that will be very costly. So generally 3 to 5 layers is what is preferred. This is FTIR analysis. I'll not go into details, but this is how an FTIR of graphene looks like. AFM, this is how an AFM looks like. AFM is atomic force microscopy. This is Raman spectra. Raman spectra decides that how good is your graphene. So all these tests are to see that how good your graphene is. So you can go into depths into each of them, or if you have any question later on, I can go into the depths for that. Raman spectra goes with graphitization, degree of graphitization, how much the product has. So the degree of graphitization should be low. The lower the degree of graphitization in your graphene is, so this is just a thumb rule. The lower the degree of graphitization, the better your graphene is. And if it's a graphene oxide, then even better, because graphene oxide should have more number of oxygen oxygen peaks, oxygen related peaks. So you can see a Raman and see that how good your graphene is, and you can take a TDS from the supplier and get to know that how good your graphene is. Nobody should be able to fool you, because in terms of graphene, anybody can fool anyone if you don't know the right technological parameters. So this, you can see the tensile strength. So how it affects is basically, and this is just like 0.1 weight%, 0.3 weight%. So this is making it more. I mean, it's reducing it, reducing its elongation at break. So it is just reducing, making it more brittle, but also the tensile modulus increases. And if you have different kinds of functionality in the graphene, then you can play around with the tensile modulus and the flexibility both. But the tensile modulus is bound to increase. This is the thumb rule. This is the contact angle. Contact angle on the left side, you can see it is an super omniphobic surface, so super hydrophobic, you can say. And on the right hand side, it is just hydrophobic or partially hydrophobic. So the more the water or whatever liquid they're using, the more rounder it is. The higher the contact angle it has, and the higher the contact angle means it has that property of hydrophobicity. So graphene gives you omniphobicity. Omniphobicity is hydrophobicity and oleophobicity both. Hydrophobicity is it is repellent to water, and oleophobicity is it is repellent to oil. So it gives you both, and both are actually opposite of each other. Hydrophobic materials are oleophilic, and oleophobic materials are hydrophilic generally, but this gives you both. Then this is how a graphene oxide coating looks, especially with our white graphene. It causes almost no change in color. And in paints, there is a major task. You have to lakhs of rupees are spent in color matching and getting the desired color. So with white graphene, you will not have that much of a problem. XRD analysis is basically the peak. The lower the peak is, the higher the exfoliation is. So here in the A peak, you can see the first peak is somewhere around 9 to 10 degrees. That is 2 theta at 9 to 10 degrees. It's a low value. And graphene goes up to 28 degrees also. Okay, so the lower the value is, the better your graphene is, the higher the exfoliation it is. Then you can see paints with graphene as additives. You can just take a screenshot or just go through it once. I'll give you 5 seconds. Yeah, so these are for different kinds of applications, for cultural heritage materials, EMI shielding, discrete spatial sensing. For sensors it is used, for coatings painted on tunnels and highways. They have a different kind of application scenario where they have to light up in the dark as well. So you can do all those things with graphene. Salt spray test is how a salt spray test looks like, and graphene can give you 1000 odd salt. Yeah. Then we have anti-static property. Anti-static is a very, anti-static agents, if you go and see from maybe BYK or some kind of big companies. So anti-static agents are very expensive. It is a good way to reduce your cost in terms of anti-static property. Why it is anti-static is because it is highly conductive, and if something is highly conductive, it gives you good EMI shielding and good anti-static property both. So anti-static property is the dust will not settle on the substrate, so the dust settles, like you don't need cleaning if you have painted indoor or outdoor wherever, and if dust is settling, the aesthetics go down. So anti-static property gives you that dust removal thing. No dust will be settled on it. And for advanced applications where you really need anti-static for your day-to-day work, it is not just for aesthetics, but you really require anti-statics. And anti-statics, the extrapolation for anti-statics is EMI shielding. So for military applications also, it is very useful. In fact, I have also worked for few military applications with graphene. So these are the for textile applications also, it goes into for increasing its anti-static property. It goes into anti-static coatings, electronic devices, polymer blends. It's highly versatile. Then solvents for graphene oxide, as I told you, there are many solvents. You can play around with the Hansen solubility parameter. There is a parameter called as Hansen solubility parameter, where HSP. So HSP decides the polarity, or whether a substance goes well into a polar solvent or a non-polar solvent. But this goes both into polar and non-polar. Although the solvent has to be slightly polar, which many solvents are slightly polar. Not many solvents are completely non-polar, but many solvents are slightly polar. So in that way, graphene is suitable to a large plethora of solvents: water, alcohols, dimethyl formamide, DMF, DMSO, dimethyl sulfoxide, N-methyl-2-pyrrolidone, NMP, even surfactant solutions for exfoliation use, surfactant solutions, and all kinds of surfactants. Although graphene oxide and graphene have a negative zeta potential, so positive kind of surfactants like CTAB, cetyl tert ammonium, so CTAB is used, of few kind of surfactants which have a positive zeta potential. So then that would bind to the graphene easily. Graphene in polymer nanocomposites, general usage as polymer nanocomposites. So it is used in solar cells, it is used in sports applications, aerospace applications, energy industries, water treatment, energy production, even in biotechnological applications for medical equipments, drug delivery, DNA splicing as well. So it is really, a huge plethora of applications are utilized in it. Then the thermal enhancement, as you can see. So this just this graph is called as a TGA, thermogravimetric analysis. So all this graph is telling you is that by adding graphene oxide, very small percentage of graphene oxide, the thermal resistance increases. So from A to E, so the virgin polymer is A, and it is shifting up, shifting up and towards the right side. So that means that the thermal resistance is increasing, and just by adding 0.1 or maybe maximum 1 weight percent of graphene, you can have a thermal stability increased by up to 50 degrees Celsius. So whatever 50, or you can play around with that. 50 to 100 is a good range. It does not go beyond 100, but 50 to 100 you can play around with. You can increase the thermal resistance, especially utilized for electronic applications where even small temperature deviation creates a major havoc. Geo-based membranes, you can see, I will speak more about the membranes, and especially for polyether sulfones. So polyether sulfone is one polymer which is quite expensive, and it is used for RO membranes, reverse osmosis membranes. RO membranes is a whole different ball game. But and this is what we are importing, big companies like Kent, Aquaguard, or maybe whatever you see. So they big players and even the medium players, they are all importing graphene from outside. Nobody is making it indigenously. So this is one opportunity where we can really do wonders within India, especially with the Make in India thing going on right now. And we have also tested a prototype with the membrane. It is giving us good results. We are working more on how to, because we have just used a very cheap polymer for our research, not polyether sulfone, but something very cheap, which is generally not used in RO membranes. But we have incorporated graphene in it, and it is giving a polyether sulfone kind of a performance. Then water treatment, as I told you, applications in water treatment. So water treatment is done majorly by two ways. That is RO, that is a reverse osmosis membrane. So one is kind of a chalni you have, like where the liquid is entering directly to the surface and getting purified and then coming out from the other side. But here in RO membranes, it is a circular kind of a membrane where water flows tangentially and then again meets the stream later on. So for both these kind of membranes, graphene is a very good candidate for water desalination, even for selective ion capture, for ion exchange reagents. It is being used, in fact, in ion exchange reagents, because the surface activity and the surface area of graphene is very big. I would say that 1 gram of graphene has a surface area of 2 football fields. Okay, it is that big. So the surface area plays a very big role in desalination or ion capture. You won't have to change the membrane many times, and also it is selectively permeable to heavy ions. So being selectively permeable, it can be engineered to what kind of ions you want through it and what kind of ions you want trapped. Especially with heavy metal ions, it's very efficient. Graphene composites in batteries, you can see that even for piezoelectrics and all those applications it is used. Piezoelectric is nothing but, for example, a quartz crystal, you apply pressure to it, so current starts generating. You can see the example of a tap here, that a tap is partially open, now the tap is fully open. So you can just change the pressure, you can apply pressure on it, compress it or elongate it, and then the current through it changes, it generates current. So it is very good candidate for this as well. And it is widely being used in batteries. At the market analysis and forecast which I showed you earlier, it had the batteries component as a major component in it, as one of the major components. So Geo and graphene both have high capacitance, very good capacitors. Capacitors are nothing but which can store charge within them. So okay, now CNT is mentioned in this graph. CNT is carbon nanotube. I'm sure most of you must have heard about carbon nanotube. So carbon nanotube is nothing but a graphene rolled up. Okay, so if you open a carbon nanotube, if this is a tube and if you open it, the sheet you will get is graphene. So there's not much difference between CNT and graphene. So all the properties that you can get from CNT, you can get from graphene, and CNT is much more expensive than graphene, much more expensive. So at least 10 to 100 times more expensive than graphene of the same volume. So you can make your own decision whether which application you want CNT, which application you want graphene. And you can see the charging discharging characteristics of graphene, and because of this it works well with anti-corrosion as well, because for anti-corrosion and self-healing paints, self-healing, or so self-healing paints require a very good charge and discharging characteristic, and for anti-corrosion as well. So you can see there is almost no energy loss between charge and discharge. The specific capacity is almost the same. The cycle performance, you can see it can last up to more than a million cycles easily. Yeah, regional analysis for geo batteries. You can see North America is leading the chart. So India should be there in the scenario within the next 3 to 4 years. I think next 3 years will be really good for India in terms of growth in the sector of graphene. This is the market forecast. It will, reverse osmosis membranes will be a market of 14.1 billion by 2032. From it is already $7.5 billion in 2022, and in 10 years it will double. You can see the future scope. Here it is. But in this, I would like to add that future scope is the best for India. These are good on papers. These look good on papers. North America, and Middle East and Africa, Europe. Africa is also upcoming. Africa, a lot of graphene being made in India is being exported to Africa as well. So Africa has become one of the major importers of graphene. It's a very versatile kind of a field. And Asia Pacific and Africa, these two have a very high potential, and I think that they will lead the charts. They might come at the level of US soon. Thank you.
Thank you, Siddhant. Sorry. Go ahead, Tik.
Thank you, Mr. Siddhant. It was wonderful to have gone through the techno-commercial aspects of graphene, in fact, or graphite. And I'm sure people must have, fellow UDCTians must have enjoyed it. Now, yes, the questions are open. Anyone can go ahead, please.
Can I ask question, Tik?
Yes, sir. Yes, sir. Please.
Okay. Good evening, everybody. Siddhant, very good presentation. Just wanted to know one thing. How is graphene? Because we have been hearing graphene for many years, and you also mentioned about military application. And carbon nanotubes have been trying to make a dent into the bulletproof jackets or armoring of the products and on. Still not very there. So how much have you gone into that? Of course, you have a lab in IIT Delhi now working on it. And so how far have we gone, and how much is the application? And which is the biggest application where you are selling today as you are having a commercial thing? Just two questions, and please.
So, sir, in terms of military applications, so as you said, bullet penetration. So it does not it is not going in that application as of now. It is going in the spying application, and because majorly it is going in spying application, because in spying you need radar invisibility and you need EMI shielding. So these properties are really being given at a good rate, because the reflectivity, emissivity, all these kind of parameters are a certain milestone for military applications, and graphene is a very good candidate for that, and it is majorly being used in military applications for spying purposes, and for increasing the modulus, like for the tanks and for all these, the inner parts of a tank, the inner parts of a tank or the inner parts of a flight of an aircraft, wherever the plastic is being used, because graphene does not go very well with metals, but it goes very well with plastics. So you can have a reduced weight, So just for example, I'll tell you the super sports cars that have come out now, they have 90% carbon fiber in them, 90%, 91, 92%, and all those, but they are being sold because of the, I mean, that is their USP, that they have carbon fiber. The entire body is being made from carbon fiber. Because of that, they have lightweight and everything, but the same properties uh, can be achieved by just 5-8% graphene, 3 to 5-8% graphene. So it goes into tensile modulus improvement, lightweight application. But for the bullet penetration, the technology is different, sir. For the bullet penetration, they are using non-Newtonian fluids. So when the bullet impacts it, the liquid inside that becomes like a solid. It is like a liquid only, but at a high pressure, it changes into a solid, and it stops the bullet from penetrating. Not only this, but there are many more technologies as well. Now the major application that we are selling it for is polymer nanocomposites. Same for the lightweight and robust application. Second is for anti-statics. We are selling it for anti-statics. Third, which is a good, I mean, where it still needs some improvement, is anti-corrosion, because anti-corrosion only price point is an issue in terms of anti-corrosion. So anyone who requires only anti-corrosion from graphene, I would not recommend them that. I would say that there are more number of anti-corrosion inhibitors, which are at a much cheaper rate. So the graphene that we are selling, I mean, that is available and that we are selling in India is approximately 35,000 rupees a kilo, and the corrosion inhibitors that you get are between 1,000 and 2,000 rupees a kilo. So that's a huge difference. But if someone wants all the properties like anti-statics, omniphobicity, scratch resistance, mar resistance, chemical resistance, all these kind of, so specialty coatings, they can go for graphene. Yes, sir.
Thank you. Thank you very much.
Thank you, sir.
Hello.
Yeah.
Yes, any more question, please? Please go ahead.
Can you hear me?
Yes, sir.
Yeah. So, hi Siddhant, this is Dr. Mohanlal Digar from Pidilite.
Hello, sir.
Thank you so much for your beautiful and informative presentation. In fact, we are trying to explore graphene, but this actually came to us from the mail you people have sent to Ajay Parikh. So we are thinking about some of the application in adhesive as well. So as you mentioned in paint application, there are certain properties which are improved. So only I have one concern, though you have shown in one of your slides that there is no change in color.
Yes, sir.
However, maybe the quality of graphene is not that good when we are trying to disperse in our some transparent adhesive medium, be it your emulsion system or some solvent-based system. The color is changing to blackish, grayish to blackish. So is there a solution for that? Whether we are using the graphene which is not of right quality or something, some new grade or some special grade is to be used. If you can highlight on that, please.
Yes, sir. So graphene is generally black in color. The graphene that you should use for no change in color, actually, I had said that earlier. Maybe you missed that. Is because is white graphene. So white graphene is actually again two things. White graphene nowadays, this white graphene trend is being said for boron nitride. There's this product called boron nitride which is being sold as white graphene, but it is just a slang, you can say. It is not actually white graphene. White graphene, only 3 manufacturers in the world are there. You can go with white graphene company, which is there in Australia. You can go with our company, Sunshine Chemtech. We are based in India, and there's one more company in the US. So white graphene you should use if you want no change in color. Otherwise, graphene, if it is changing the color of your adhesive, does not necessarily mean that it is a bad graphene. If it's a good graphene or bad graphene, you should ask them the TDS, or you should do some test on your end. I think if you just do XRD, X-ray diffraction, that will be enough. Yes.
Mm-hmm. And when you talk about there is no change in color, whether the polymer system wherein I am trying to incorporate, that will remain transparent to light?
Yes, sir. So, no, the transparency will go down. The transparency will definitely go down if you are adding graphene. But again, that depends on how much percentage you're adding. You will not be adding above 3-8%, that is for sure. But uh, uh, graphene, even if you add white graphene, the change in color won't be there, but the opacity will definitely go up a little bit. Yes.
Okay. Okay, thank you so much.
Thank you, sir.
Yeah. Yeah, Siddhant, I think one of my colleagues will also would like to ask something.
Yes, sir.
Myself, Dr. Rakesh Manna. I just have one question. How can the graphene be white? Are we mixing some other additives so the graphene either be transparent or black? If it is single layer graphene, bilayer graphene, it will be transparent or black. But white, how can it be white?
Yeah, so that is our USP, sir. Actually, okay, now I'll answer you that question, that why it is coming as white is because in nanomaterials, if you change, like, that is how quantum dots also work. So in nanomaterials, if you change any kind of a chemistry or any kind, like, our white graphene is very highly exfoliated, so the distance between the layers is very high. The d spacing is very high, and when d spacing is high, or when the inter layer distance is changed in nanomaterials, the color also changes. So this is one thing in nanomaterials that is there. So our product is 3 to 5 layered. It is it's not like completely, I mean, the polydispersity is there, so 3 to 5 layers is there. So even if you, I mean, if you go for single layer graphene, that will be the best option, but that will be very expensive for you. So single layer graphene will give you all kinds of applications, whatever you need. Even opacity, it will not increase much, very little, very maybe not even visible to the naked eye. But it will be very expensive. So the same thing you can get from 3 to 5 layered also, if you can sacrifice a little bit of your opacity. That will be great. Yes, sir.
Great. Thank you so much. If we want to explore white graphene in our system,
Yes,
whom
sir.
should we reach out?
So you can reach out to me. I will just paste my number here in the
Please.
chat. Yeah.
Thank you.
Thank you, sir.
Hi, Mr. Siddhant. This is Tekchandani. A very, very simple understanding I want to make.
Yes,
I
sir.
understand that this graphene or graphite membranes can be made for the filtration of water. You somewhere mentioned that a seawater can be used for drinking purpose also,
Yes,
very
sir.
fast and efficient way, right?
Yes, sir.
Is actually this product of yours, or graphene for that matter, being made to use in the household filters that are used in the aquaguards and what do you call it, the RO filters and all that?
Yes, sir. So we are in talk with a giant, I won't name them as of now, but like, we are in talk with them, and they will soon commercialize it, because we have tested a prototype already, and we have got good results from there. So this will be a game changer actually, if we are able to use graphene in our household this thing water filters. It will be a game changer, because nobody is right now using graphene in their this thing RO membranes. The thing with RO membranes is that it is a tri-layered membrane, and in those 3 layers, the major layer is polysulfone, polyether sulfone. So PES. So PES is, I mean, in India is not a good option for PES sourcing. So that's why they have to rely on PES. That's why we are relying on the foreign bodies to import the RO membranes. But if we are able to incorporate graphene in a cheaper polymer, maybe even PVC, so uh, there, if we are able to get a better performance or a equal performance at PES, we can start indigenous manufacturing. So it will take probably in the next 1 year or two. we will have those kind of filters in our household as well, sir. Not right now. Yes.
That's really wonderful. Wonderful. Anybody else who wants to ask the question?
Yeah, I am Anil here.
Yes, sir.
I have a question for Siddhant.
Yes, sir.
Is graphene is tried in a formulation of dust suppressant?
Dust suppressant, yes, sir. For anti-statics, yes.
So you mean if graphene is used is one of the component in dust suppressant, the dust can be suppressed, right?
Yes, sir. Easily.
Especially in mining and all that, right?
Yes, definitely.
Mining.
Because why does dust rise and why does dust accumulate at a surface is just because of anti-statics. I mean, it's just because of statics. Static electricity is generated, and because of that, it is just needs to what happens when the dust settles down, then the zeta potential of the substrate nullifies. So the potential energy has to be the least. So if you are getting that same property from anti-statics, there will be no kind of dust accumulation.
So do you have a suggested formulation?
Sir, yeah, if you can tell me your system, and so it varies from system to system, but generally 0.3 to 2 weight% will do the job in mostly in any kind of paint system. It will do the job.
Okay, I will connect on your mobile.
Sure, sir. Please.
Thank you so much.
Thank you.
I think it was very interactive, very nice. I'm sure. Let's give a couple of moments more for anybody else to think in terms of asking a question. Siddhant is here to answer your questions. Any more questions, please?
How many
Yes,
companies are already there now in India making these graphene products?
So,
how many companies are already in this business in India?
Sir, yeah, so I'll tell you, Hexorp is one. I mean, apart from us, Hexorp is one. Hexorp is doing well, but Hexorp deals with Hexorp deals with a lot of different kinds of products. It is fully in India made. I mean, the owner is a good friend as well, so they are doing good. Then Reliance had stepped into graphene, but Reliance had some other plans. I mean, they really invested a lot in their graphene sector. But black color was one issue which they could not resolve, and maybe some other issues also. They dropped out of the graphene thing. Maybe they gave their business to someone, some other third party, or I don't know what happened. But Reliance, came into it and sustained for approximately 2 years, 1.5, 2 years. Then Aditya Birla is doing really good. Aditya Birla Advanced Materials, they are doing very good in graphene. But white graphene is only being made by us, Sunshine Chemtech. Yes, sir.
And you said the total global demand is more than 100,000 tons.
Yes, sir. More than 100,000 tons. Yes, global demand. And in Australia, I would say Australia is our major competitor in terms of white graphene. They are making graphene at 4,000 tons annually. And what we are making is almost 1 ton per month. That is 12 tons annually. And that too, it's a variable figure, but so that's our competition right now. So I feel if India is really a huge potential, because the number of industries and the number of paint manufacturers and polymer manufacturers and so many of them are there, but they are not educated enough to not educated in terms of the recent trends that graphene is a thing to invest in. They can in fact increase their, if someone is making a anti-corrosion, just mentality, it's just mentality that if I'm making a anti-corrosion paint, and if I'm if I just want a corrosion inhibitor and somebody is giving me graphene, If I know what graphene is, or if that person is able to explain me, and if I'm able to agree, then I can increase the applications of my paint and sell it as a anti-static paint, conductive paint, hydrophobic paint, omniphobic paint, and market it in such a way, So this all comes down to mentality as well, that you can increase the bandwidth of your applications. This is there, sir. So still,
I think there's a question. Aboli has raised a hand.
Before Aboli you go, can I request everybody who can open their video on, so that maybe we can take a picture for Udaan. Aboli, go ahead, please.
Yeah, so hi Siddhant. So
Hi.
as you are working in this segment from some years, so do you think there are any policy interventions which are required in this segment? And if yes, what are the policy interventions you expect from government side? Because I work with Invest India, and sometimes we have meetings with Department of Chemicals and Petrochemicals as well. So if you have any suggestion, do let me know.
yeah, sure. We can connect later on.
Yeah.
Well, wonderful. I think it was very interactive, very nice, very well explained. I'll request Mr. Dinesh Chopra to please speak up a few words about the lecture and about the future of our UA NCR series, lecture series.
Oh, thank you. Beef, very nicely done. And Siddhant very nicely conducted the lecture, very informative. I think it will bring a lot of opportunities in the graphene area, and good opportunities for the chemical industry in India. And as far as UA is concerned, we will continue to have these lecture series and also look at face-to-face meetings as much as possible, because face-to-face meetings cannot be replaced by a web thing and interaction among our UA members. So I think we'll continue doing that, and look forward to participation for everybody, and bring your friends and bring more number of people into our meetings. I think thank you very much, and thanks Beef for conducting this session.
I have a request. I have information to share that this program, or this UA NCR chapter series, technical chapter series, is actually a push and a brainchild of our Mr. Shyam Bang, who is the person who actually pushed us to get into it. And really, we are now finding it wonderful. So that, it's actually bringing us back to our UDCT in days, that we are learning something and in a better manner. I'm really grateful to everyone who have joined today. I'll request, tell your friends to be with us, more number, so that, we feel motivated. Thank you so much, everyone.
Thank you, sir.
Thank you.
Thank you. Bye-bye.
Bye-bye.